All right, Catherine, here's your personalized explanation now that I have my fancy iPad and whiteboard software all up and running. So what I would do is for object 1, it looks like you were on the right track here. It obviously starts from 0. I would say its displacement is simply x1. And what I'm going to do is I'm actually going to, for this one, say that down is the positive direction. So that means that my acceleration is going to be a positive 9.8 meters per second squared, and my time is going to be, like you have, t plus 2.4, where t is the time for the other object. For the second object, we'll say that its displacement is x2. Its initial velocity is 40. In this case, I'm saying up is the positive direction. And I'm being consistent throughout, so that's okay, throughout each object. Its acceleration is negative 9.8 meters per second squared, and we know that its time is t. So here's really what I'm thinking, is that the one object is going to start here and fall some distance x1. The other object is going to start from the ground and go up some distance x2. And we know that those distances just have to add up to the 80.5 or 81.5 meters. So the way I'm going to eventually link these two is say that x1 plus x2 equals 81.5. So what you were doing wasn't wrong, but I think it was a little bit confusing because the one was falling and actually would have had a negative displacement. The other was rising and would have a positive. And so I think that made it more difficult for you to combine the two. This is really the key concept that needs to happen, is those two need to add. And so the one I'm going to say is falling with some positive displacement, because I'm going to say down is the positive. The other is rising with some positive displacement, and those two displacements have to add up to 81.5. So I can go ahead and write my equation. In both cases, I'm using the VIT plus 1/2 AT squared equation. And so what I end up getting for object 1 is that x1 is equal to 0t plus 1/2 times positive 9.8, since down is the positive direction, times t plus 2.4, that quantity squared. And for the second equation, x2 is going to be equal to 40t minus or plus 1/2 times negative 9.8 times t squared. So I'm going to go ahead here and simplify both of these a little bit. So now that I've simplified them some, it looks a little bit messy, but it's actually going to work out quite nice in 1 second. I'm going to then put them into this equation that I have here. So we're really going to say 4.9t squared plus 23.52t plus 28.22 plus 40t minus 4.9t squared equals 81.5. 4.9's cancel out. That's the nice part that I was talking about before. And so what we're left with is 63.52t plus 28.22 equals 81.5. And so we can go ahead and solve that for t. So I end up here with a time of 0.83879 seconds. Okay, so I'm going to then take that and use that to find the distance here. And so we really can plug into either equation, either x1 or x2, although I guess it's looking for height above the ground, so that would really be x2. So x2 is going to be 40 times that time minus 4.9 times that time squared. So I end up getting that x2 is 30.1. If I check it with x1, 30.1 meters, if I check it with x1, they should add up to 81.5, so let me do that real quick. It looks like they do. For x1, I'm getting 51.39. Alright, so with rounding, that's going to add up to my 81.5. So there you go, Catherine, your personalized solution for that problem. By the way, I just have to get this in one time. I hope you had a pleasant Saturday, though, last weekend. Talk to you soon, favorite student ever.